that's one of the themes I'd like to pull out of here is hustling and focus. The question you're trying to answer, try to get to that question as quickly as you can. And you can always backfill the details later, but if you can get a quick look at the answer, that'll often get you 90% of the way there, and then you can redirect your efforts if you need to or take a different path.
Hello and welcome to the Being an Engineer podcast. Today we are thrilled to be speaking with Tony Dietz, who is the President of Paxauris, where he leads the development of innovative hearing protection products. With over 30 years of experience, he previously worked at Creare, leading R&D projects in advanced airdrop technology and cryogenic systems, and at NASA Ames as a senior research scientist. Earlier, he served as an engineering officer in the Royal Australian Air Force. Tony holds a Ph.D. in mechanical engineering from the University of Oxford and a Bachelor's in Aeronautical Engineering from the University of Sydney. Tony, thank you so much for joining us today.
Thank you, Aaron. Pleased to be here.
Well, this is episode number 4 of an ongoing series about how to accelerate the speed of engineering. And I've been really excited to talk with you about this. I think we've got some great questions to go through, and it's going to be really beneficial for everyone who's listening, all the engineers out there who just want to get things done faster, cut through the busy work and get to results. So before we get into how do we speed things up, let's maybe talk for just a minute or two about what are some of the things that you have seen slow engineering projects down unnecessarily?
Yeah, well, thanks, Aaron. These are, I think, very worthwhile questions and a great goal. I've had a varied background, as you saw, experience as a research scientist, but also as a flight test engineer, and then as a research and development engineer, and now in the entrepreneurial startup community. And each one of those, I think, brings a very different perspective, but also there's some common themes which run through. So I'm going to pull from all of that in our discussion, hopefully.
Wonderful.
But to get to your question, bottlenecks, I think the big one is communication. I think always communication is key. And that's one where I've seen really smooth and speed up the process, but also slow things down. And so when I'm kind of onboarding or briefing new engineers, I always tell them, like, at the beginning of a project, any job, communication is critical. And you always have to ask for 3 things. One is the objective of the job. The second is the timing or the deadline you need to meet. And the third is level of effort. And that's sometimes what's missed in the communication. You may be asking someone to do something you think will take them an hour, and they set off for a week or a month-long task because you haven't communicated the level of effort you want from them. And that's important. And then it's also important, as that job gets communicated to people working for the engineer, that they also communicate those 3 things: what the task is, what the timing is, and what the level of effort that they want. And then keep the loop going down to the people you're tasking and up to the person who tasked you. And that's also critical. And that's usually where a job falls over, is if that loop's broken and someone's not reporting back. And I always tell my engineers, don't assume because you gave someone a deadline that they're going to keep to it, and then call them up on the day the product's due, or you expect to get your component from a supplier, and then they say, it's not going to be ready for another month. And you said, well, we agreed on this deadline. And they say, well, things change. So you have to be the squeaky wheel. You have to be always in the loop. You have to be the one that they know, we got to make sure we meet this deadline because he's been on the phone to us every week telling us how important it is. So we won't let his job slide. And I have a good example of that from my time at NASA. I was building a wind tunnel, and I went to the kind of welding shop where they were making the contraction. That's the big open face at the start of the wind tunnel, which, sucks the air in. And they said, when do you need this by? And just new in America, And so I said, about a fortnight would be fine. And then if fortnight means 2 weeks in Australian or English, but I came back to them 2 weeks later and I said, how's it going? And they said, we haven't started yet. And I said, but you agreed on a fortnight. And they said, yeah, we didn't know what that meant, so we just ignored it.
That's such a good story.
There was poor communication either way in that case. But then it took me another 2 weeks to get my wind tunnel. So that was on me.
Wonderful story.
Yeah. So that's what I say. Don't just assume that people are keeping to it. I had a couple of others. I think I've used bottlenecks. One is overworking the problem. And that comes back to that level of effort of communication. Often, you'll give a new engineer a task and they're so gung-ho that they'll just work it to the nth degree. And that'll slow the job down, but that also happens to more senior engineers as well. And that's one of the themes I'd like to pull out of here is hustling and focus. The question you're trying to answer, try to get to that question as quickly as you can. And you can always backfill the details later, but if you can get a quick look at the answer, that'll often get you 90% of the way there, and then you can redirect your efforts if you need to or take a different path. But if you've dotted all the I's and crossed all the T's and built this wonderful foundation when you haven't even looked at the thing, that you're trying to achieve, that can be a big problem. And we had an example of this just last week. My company is developing a new type of earplug. It's a inflatable earplug, which is easier to fit and more comfortable. And we were looking at the Australian standards, the testing we'd need to do to get it qualified in Australia. And they include this heat soak. It's like 50 degrees C, so it's like 120 F for 16 hours between 5 and 15% humidity. And then you do your test. Now that is not included in any of the American regulatory testing we've done. And so I tasked my junior engineer to go and get us, tell us we're going to pass this test before we go off to the regulatory testing and spend a whole lot of money to find out something we hadn't seen. So I checked with him the next day, and he says, well, how much can we spend on this? Because he's priced out all these incubators, and he says, like the cheapest I found is about $5,000. They go up to $10,000. And I just looked at him and I said, we live in Phoenix. It's 100 degrees outside and about 10% humidity. I just came in from the garage. Let's put the earplug in a cooler in the garage. And we brainstormed it a little bit further, and he came with the great idea of adding a $5 heating pad used for lizards in aquariums. And we got the test done for $7 and the results ready the next day. So that's a good example of what do you need and how quickly can you get there.
I can already tell this is going to be a fantastic episode. These are wonderful, wonderful examples. They ring so true for me, just music to my ears. Your story about the fortnight.
Oh, yeah.
Go ahead.
Oh, sorry, I was cutting you off, but my final one is don't ignore the customer, and I'm sure that's one that you can relate to. But so many times, if we're developing something but we haven't asked, run a field trial with customers or got out and talked to the end users, then we'll just develop the wrong thing, and you can't even trust your contract or the person tasking you. You really need to talk to the end users who are your true customers and make sure you understand what they want.
Yeah, excellent. What are some tools that you have used to fail fast and fail inexpensively?
Many tools. Often it's whatever's at hand. And this trying to find the quick answer, the good example was that earplug in a cooler in the garage. Use what's there. One surprising one I have used a few times is Lego. Often if I'm designing a mechanism or trying to get a quick answer to a problem, you can build something out of Lego or use a Lego robot or something like that to get you to the answer. And so sometimes you'll be working through the lab and you'll see all this high-tech equipment and you'll see this little Lego machine running. And that was just the quickest way to get to the job. And having coached middle school Lego League robotics teams, I'm surprised how much you could do with Lego, but that's also possibly the tool I know. But for example, we have in our lab here a sound booth where we do testing of our earplugs, and so we wanted to fire off a starter's pistol in there to get loud impulse sounds, so we could measure how the earplug works. And so I was trying to figure out how we could remotely activate the starter's pistol, because we wanted to close up the sound booth and then not be exposed to the noise ourselves while we're doing multiple firings. And it turned out the easiest way was just to get the little Lego robot, drive the Legos on a mechanism which pulled the trigger, and then we could Bluetooth into the robot, and now we had a remote firing mechanism for our starter's pistols.
That's fantastic. It reminds me of, are you familiar with the cooking style sous vide?
No.
It's where you warm water up to whatever final temperature that you want your meat cooked at. Maybe it's 150 degrees or 140 degrees, whatever. But it's this just kind of circulating bath of heated water. And so you cook your meat in there, usually in a airtight, not a Ziploc bag, but like a vacuum sealed bag. So the water doesn't actually touch the meat that you're cooking, but you leave it in there for a long time, 3 hours, 4 hours, 5 hours. So the meat very slowly comes up to temperature, but then it just sits at that temperature. And so you get a very, very even and accurately cooked piece of meat. And then you can throw it on the grill for 30 seconds, and kind of charbroil the outsides for that nice crust. But there's a tool that is sold. It's fairly inexpensive, maybe $100 for one of these sous vide. I don't know, call it a wand, and it kind of hangs off the side of a pot. And there's a heating element on the bottom, and there's a little pump that circulates water, and it does a really great job of bringing fluid up to a temperature and holding it there. I mean, it's not like an industrial piece of equipment by any means, but for $100, it's a great solution to do this. And we've actually used that in some testing that we've had to do. Maybe like you're a junior engineer, you go out and you look for an industrial solution. Well, the cheapest one's $3,000, right? Well, let's take this sous vide wand and just stick it in, and $100 later, great, done. So I love all the things that you're saying.
So true. And that's another mantra is buy, don't build. And if someone's already done all this development and reduced it to practice and scaled it, we can benefit from that.
Absolutely. Yeah. One of the areas where I have seen engineering slowed is when engineers don't feel psychologically safe to speak their minds and to share what they're really thinking, whether it's a concern or maybe an idea about how to do something better. How have you been able to create environments where your team feels really safe to be a little vulnerable and share their ideas?
Yeah, that's a really great point, and I think very important. At my previous job, I was the new engineer supervisor, so I would onboard all the new engineers, and I think that onboarding the new engineers is a key part of that, making sure that they understand the expectations of the organization, how to operate in it. We would give them a list of 10 commandments for new engineers so that they wouldn't, they'd know how to fit in the culture and not do the stupid new engineer things everyone does. I think that's important. I think buddying someone up when they start is really important so they know a safe person they could go to ask all those questions. Another key one is, I think, something which we've done here is to have environments where new engineers feel they can ask those questions. And so, for instance, one thing I noticed coming from England, Australia to America was the lack of tea time. This is another theme I have for productivity. But in England and Australia, there was rigid tea time at at 10 a.m. and 3 p.m. every day. And whatever group you're working in, be it a military unit, be it a laboratory, or a research group, everyone would come together for tea in the tea room, and you'd have the commander there all the way down to the most junior engineers. And that was always a very relaxed environment where if you had a question, say, for the group captain, you could go up and say, "Oh, sir, I had this thing I was wanting to ask you," without having to go into his room, stand at attention, salute him, interrupt what he's doing, and ask you a dumb question. So making those environments is important. And I found in the States, you have to be intentional about making those environments because it doesn't happen organically through tea time. So we've, at this startup company, which we have now, we've intentionally tried to create that situation where the interns or the junior engineers can interact with the senior engineers and ask their questions without feeling like they're interrupting them or imposing on them. So we now have a 9:30 stand up every morning for 15 minutes, just where we all talk about what we're doing that day and if anything's blocking us and if anyone has any questions. And that often then will flow into more detailed conversations. And I think that's just creating that environment where it's not a very official meeting or something, but you can get your questions answered is important.
Tea time. This is the first time I have ever heard tea time recommended as an engineering productivity tool.
Absolutely. It's a productivity tool.
I love it. Yeah. Yeah. Okay, great. Well, let me take a very short break here and share with everyone that the Being an Engineer podcast is brought to you by Pipeline Design and Engineering, where we don't design pipelines, but we do help companies develop advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services. Learn more at teampipeline.us. The podcast is also sponsored by The Wave, an online platform of free tools, education, and community for engineers. Learn more at thewave.engineer. We're privileged today to be speaking with Tony Dietz. I almost feel like I should call you Sir Tony Dietz. I don't know, just the English, Australian, and the Royal Army, and you're so knowledgeable, clearly. But we'll stick with Tony for now, I guess.
To wait for the knighthood to come through.
It's probably not far off,
no,
right? Just around the corner, I'm sure. All right. When you have, and maybe I'm sure it is the case right now at Paxauris, working in cross-disciplinary environments, what are some best practices that your teams have implemented to facilitate not just communication, but communication between different, across different functions, electrical engineers to mechanical engineers to software engineers, et cetera?
Yeah, that's with us, we're a small startup, so we're three to five engineers. And so those cross-disciplinary communications have not really been such an issue because you can just go and talk to the person. The meetings I talked about are a good forum to do that. Where that's been, I think, the most challenging has been when we're working with consultants, outside groups. Often that is where those problems fall over, and it's usually in specifications, requirements, and documentation. One of our big, I think, challenges has been adequate documentation. As a startup, when I work with one outside company, then another, and there's through the pandemic, there was a lot of changeover of personnel where you get someone up to speed and then they'd leave, and you have to bring another person up to speed. So making sure all that documentation is captured, and something that might make sense to you in a meeting 3 months later or 6 months later, you've forgotten completely why we had to design the antenna this way, or why we couldn't, use a button here, or some of these kind of questions. So we started just trying to capture that information when it happened in as big design specification documents, and then a whole bunch of other documents, which we then keep as living documents and continually update. And that has been a huge, huge help. And that's also I found in previous things. If something's outside your expertise and someone explains it to you and you make a decision, write it down and write down why, and then you'll be able to refer back to that.
How do you organize those notes? One of the challenges I've found is maybe something gets written down, but then we have, I'll be a little vulnerable right now. We have lots of SOPs at Pipeline, and every week we have a team meeting. Well, we have several, but in one of these team meetings, there's an engineer who is assigned to pick one of the SOPs and not read verbatim through the whole thing, but just remind everyone that it exists because there are enough of them out there that we don't remember all of them. And more often than I care to admit, the SOP or the standard that's shared is out of date somehow. So that's one problem. But then we've completely forgotten that this SOP even exists. Have you found any good ways to help people remember, like, where the right documentation, where those notes are kept?
Yeah, we're still struggling with that. We've tried a few different ways. Our current approach is we're organizing it by product. It was by project before. We work in Microsoft Teams, which is really a institutional platform. It's not great for startups. You need a dedicated IT person to understand even how to run the thing often. But we've picked certain aspects of that, and by organizing the teams around products, then a lot of the knowledge can be captured in that channel or in that particular team, the communications, and that makes it easier to find things. It's important the thing that you're storing all your information is searchable so that you can search keywords. And that's where coming to a few very large documents where we're just dumping all the data. It's then searchable. And even though it might be 100 pages long, we can find the bit we're looking for.
Yeah.
So I think that's important. And then we don't use, you can drown in operating procedures. Like if no one remembers it and it's out of date, then it's probably not that valuable if it's not being used, often. So I do have procedures, but they're for workflows like accounting, billing, things that you do monthly or weekly, that you need. But often on the engineering side, because we're a startup company, where we're trying to be lean and fluid and adaptable, and we don't want to be tied down in bureaucracy.
Yeah. I think if I had it to do over again, I would not create a new SOP every time something new happened. Wait until it happens a dozen times and then create an SOP or something like that. All right. Has there ever been an experience where you've introduced either a new technology or a new tool that somehow has significantly increased the speed of engineering?
So I think our daily meetings has been one that we currently has made a big difference to the productivity of our team. We started off with just weekly planning meetings. Then we added a second meeting, and then we went to this daily stand-up. And I got that idea from talking to a couple of other teams who are working remotely and especially in the software development area. We tried, adding, some of the tasking which they use in software development, but found just that daily check-in with the team was super important. It made everyone focused on what they're doing, and also it helped them to address any roadblocks they were having. And that daily basis is good because it sets everyone up for the day and then makes sure they're productive through the day. And then it also adds this element of, well, I can't say the same thing I was doing yesterday. So
some accountability.
There's a little element of accountability to keep you moving forward. That's a procedural thing. In terms of specific tools, probably the biggest thing that's happened through my career is the rapid prototyping. That's really come so far along as I've been in developing different products. And so even in the last 3 years, our earplugs are made from silicone. So we use injection molded liquid silicone rubber to make the parts. Those molds, even if you're using, single cavity, small run number molds, they're still going to cost you a couple of grand and 2 weeks to a month to make. And so just 2-3 years ago, they introduced the capability to do 3D print silicone parts. And so that for us was a game changer, because all of a sudden we could be turning around our designs in days and weeks instead of months. And so that was a really helpful thing. Another tool that I introduced into the work we're doing, so we develop earplugs and we make small changes to our design, and then we need to measure the effect. And because an earplug interfaces with the human body, then the way you measure whether an earplug's working is you play a sound for a person. They then, like a hearing test, they note when they can hear the sound at the threshold, put the earplug in, play the sound again louder, they note it again, and now you've got a measure of the attenuation. And you have to do this across the frequency range, so at eight different frequencies. It takes about 15 minutes to run this test. And then you need to run it with maybe 10 to 20 subjects to take into account human variability. So that test can take a week. And then you get your answer of whether your design has made a difference or not. And the standard deviations are huge. It was shocking to me when I went from the world of aerospace, where we're dealing with safety factors of 1.2 and standard deviations in our tests of in the percents. You test a human and suddenly your standard deviation is 50% on the mean. And you just, how can you develop something when your thing you're testing on is so variable, like whether they had a cup of coffee that morning or got a bad night's sleep will completely change the results, or whether they went to a rock concert and they can't hear anything.
Yeah.
So what we developed was a biofidelic head model, which we 3D printed. We got a scan, an MRI scan of a human's head. We segmented out the skull. We 3D printed the skull. We then put a brain simulant in there and molded the outer tissue, including the ear canals, and we put little microphones where the eardrum is. And now we had this head, which was a repeatable test platform, and that was a game changer. We could then make a small design change, test its effect on the head, and then repeat that. And the head always gave the same data. So that's another example of it's not just the procedure, but the test, the validation approach is also very important.
Purpose-built tools is what I'm hearing there, if you were to generalize it.
Yes.
Yeah. We work with a lot of motors and pneumatics here, and we found that it was taking us a long time to build a new circuit every time we wanted to control a motor for a simple test, not for a production, but just to test something, develop a new process in the lab. And we had a variety of different methods of doing this, and Arduino, or some, maybe even a cheap PLC, LabVIEW, right? There are a variety of methods that we tried. And finally, we just built kind of a general purpose controller that's really, really flexible and doesn't require any coding knowledge. It's just a drag and drop. It's not LabVIEW. It's actually a product. We have productized this because it has changed so significantly how we control motors and pneumatics, and it's so much easier and so much faster. And so that's an example of a kind of a purpose-built tool that we did internally, which has significantly increased our efficiency in that area.
Yeah, that's a good point, because if you identify where your real inefficiency is, then often you can solve that with a tool that will then pay you back 100-fold. An example of that is we were doing a flight test on an F-18. It was a loads test back when I was in the Australian Air Force, and I was in charge of the as the test director of the flight loads testing. And we'd taken an aircraft and we'd covered it in strain gauges. It had maybe 200 strain gauges on it.
Wow.
And then the test pilots were flying it through these loading conditions. And they were flying daily. And so they would go out, fly, land, and we would end up with an hour's worth of data from 200 strain gauges to review before the next flight, which was the next day. And so we found during the test series, we were just falling behind to the point where we were maybe a week behind the testing. And then if we identified a bad gauge, it had the potential to invalidate all the testing done.
Yeah.
And if you think of the cost of flying a jet for, an hour a day, that was running into the potentially millions of dollars. So we were pretty stressed out about it. And so what I did before the next series of tests was I wrote a program that then would, first of all, I had the plane before every flight do what we called a phasing maneuver. So he would just do repeated, like a pull up, a push over, roll left, roll right, bank turns, to exercise all the strain gauges with repeatable maneuvers. And then I wrote a program which just compared the strain gauge peaks and averages for that maneuver from flight to flight. And then instead of checking each gauge for the whole test, we would just run down this list and see if anything had changed. And it would then notify us if there was a 20% change in any gauge from that maneuver. And so then we went from being, 8 hours of work to analyze a flight to 10 minutes. And that was a game changer as well.
That's huge. Brilliant. That's great. How about, has there been anything unconventional that you can think of that, some approach you took to expediting engineering processes? I mean, that example you shared earlier of sticking your product in a cooler in the Phoenix garage with a heating pad, that's a great example. But anything else like that, just kind of unconventional attempts?
Yeah. Like the Legos is a good one too.
That is a good one. Yeah.
And one unconventional thing, maybe it's unconventional, maybe not, that I like to do is get my engineers into the field, get them interacting with either the end user or the customer, because I think that really gives them a better feel for the problem that they're trying to solve if you understand where it's going to be used. And engineers tend to love being head down solving the problem, but they also are good at distilling data and understanding the issues. So if you get them out into the field interacting with the end users, they come away with a very different perspective and a bigger picture, which I think helps them on their task. And an example of that is we were doing a computational fluid dynamics model of a skydiver, so a person in free fall. And this was for the Army because they were having this issue where parachutes would deploy and then burble a bit. It was called hesitation before they'd open. And if they get caught in a particularly challenging wake from the skydiver or the parachutist, then it may not open at all, which you can imagine is a bit disconcerting for the parachutist. So we developed this model to try and identify if certain gear configurations made bad wakes. And we were validating it by testing the parachutists in a vertical wind tunnel. And I wanted my engineers to all go in the wind tunnel so that they could see kind of how varying your arms and things around would affect the forces on your body and get a little bit of an understanding of how the model that they're developing interacted with the wind and the free stream. And we did a risk review, and it was knocked down by the powers that be in the company because they said, we can't afford to have engineers in a wind tunnel breaking their neck or something. But they have kids' birthday parties in these wind tunnels, and I thought the risk was fairly low compared to the benefit for the engineers actually getting to experience the thing they're trying to model. Because you can spend a lot of time in your computer, but there's nothing like understanding the real world so that you so you can answer those questions. Like I've spent a week modeling my little finger, but maybe the fingers don't even matter, right? Because it's just big hand movements. So.
We build a lot of one-off machines, custom one-off machines, and our team isn't huge to begin with. We do have a technician who does a lot of the assembly work, but we also have our engineers directly involved in doing assembly work, and we've had not a lot, but maybe a little bit of criticism here and there from a customer saying, "Why are you paying an engineer to be out here doing assembly work?" And my response to that is always the same as what you're saying. I mean, if we were building 100 of these things or 1,000 of these things, I would agree. It doesn't make sense to have an engineer out there doing assembly work, but we're building one or maybe two of these things. And it never goes together right the first time, right? There are always things that just don't fit quite, or this mechanism didn't work the way we thought it was going to. And having the engineer there in real time building what he or she designed is so effective because they can just right away figure out how to solve that, as opposed to, well, maybe if you have a technician who just does assembly, maybe they, put some duct tape on it and think it's fine, and then it breaks in the field, and nobody wants that. Now it's a much bigger issue. But we found that to be really effective for one-off builds, right? Again, not for production things, but
I
it's
agree.
been helpful for us.
I absolutely agree. And that also gives a nice communication between the engineer and the technician. And that
definitely.
instant feedback will be very important to the next design.
Yeah. Yep, absolutely. Have you learned any lessons from projects where maybe there was an attempt to accelerate engineering that backfired?
Oh, yeah. Of course. Some bad ones that haunt me to this day.
Any that you're comfortable sharing?
Yeah. Well, I think the important thing that I've learned is there's accelerate, but you also have to think of the consequences of acceleration. So there's a bang for the buck balance here. And so you need to go slow where the consequences of failure are high, and then you can go faster when the consequences are less. And so that's drilled into the flight test community, obviously, where you're testing aircraft and you're pushing the edge of the envelope. The consequences of failure are catastrophic. And so the approach is called incremental testing, where if you know there's a limit you're trying to approach, you'll approach it very slowly, bit by bit, so that you don't suddenly have a structural failure or a deep stall you weren't predicting or something like that. And in my career where I did that wrong, well, not in the flight test, thank God, but I was testing a superconducting power transmission line. This was a cable which we were developing for hybrid electric aircraft. It's an enabling technology, because if you have a aircraft, this is where the jet engines are running a generator, and then you've got electric motors distributed along the wing. And so it has a lot of advantages from an efficiency point of view. But the copper cables, because of the amount of power you're trying to transmit from the generator to the motors, is prohibitive. But if you can make use superconducting transmission cables, then the weight goes way down and it becomes possible. And also the technology would be great if we could get it to work for, say, powering the East Coast from Arizona, or America from Australia. A DC superconducting power transmission line can send power very long distances without the losses or the phases going out of whack. So that's what we are working on. We'd spent 2 years building the rig, because it has to be cryogenically cooled to around this one was running at 15 Kelvin, so very, very cold. And so we had a lot of insulation. It was all in vacuum. And we'd run out of money. We'd run out of time. We're at the end of the project. We needed to hit our goal, which was, I think we needed to send 10 kiloamps through this cable. And so we had it cool. We'd been cooling it for 2 days. I'm now in the situation where in an overrun And it's Friday afternoon. We're sitting at 5 kiloamps. And I'm like, okay, let's go for it. We can hit our target here. And we went to 8 kiloamps. And so I'm like, let's go for 10. And the joint went resistive, and you put till 10 kiloamps through a resistive joint, and the whole thing just melts. It's basically and then of course, extra funding came through, and we got an extension. But I'd blown the system. So that's when I look back and said I should have taken a deep breath, stepped away, analyzed the data, taken the incremental approach. But the like golden apple was hanging there, and I just went for it.
Was that an unforced error, or is that just an example of sometimes you don't really know and you take a risk, and sometimes it pays off and sometimes it doesn't, and there's an element of luck in it?
It was unforced in that if we'd stopped, analyzed the data, we would have seen that joint going resistive. The hint was there if we'd analyzed the data closely enough. And so pushing on without taking that step, that was the mistake. So I'd say it was an unforced error. We could have recovered.
Well, it's great that you can at least identify exactly what the mistake was, what you could have done differently, as opposed to, shoot, it blew up, but I'm not really sure what lesson to take from this. That's a win right there.
Right. And my other lesson is, you have to kind of sometimes drown out the noise of schedules and deliverables and targets and focus on the task at hand, because as a manager, that's hard to do because you've got all these other pressures on you. But if you let that win, it can cost you a big setback.
Yeah. Well, as we've discussed all this, clearly there are many factors that contribute to being able to accelerate the speed of engineering. And this is a completely unfair question. I'll put that out there right away. But if you had to choose one that you felt was the most important factor, what do you think that would be?
I think for me, it's back where we started. The hustle, know the question you're trying to answer, try to get the fastest, hustle towards getting that answer as fast as you can. And then you can always go back and backfill the details. Another challenge is knowing that you're asking the right question. When you know the question, then hustle to the answer as fast as you can. That time and time again has helped me ask the right question by answering many wrong ones beforehand.
Yeah. Okay. So get to an answer as quickly as you can, even if it's not the perfect process to get to the perfect answer. But maybe if you get 80% of that answer, that's enough. And you probably did it in 20% of the time.
Exactly. And then you can iterate to improve your solution.
Yeah.
Based on customer feedback.
Right. I have a friend who was on the podcast a little while ago, Chris Julian. He likes to say maximize goals or maximize shots on goal, which I think is just another way of.
Absolutely. That's really good. I like that. Yeah.
All right. Well, Tony, what a privilege it's been to get to know you a little bit and hear all of your wonderful, wonderful insights and wisdom about methods and protocols for accelerating the speed of engineering. Thank you so much for being on the show with me today. How can people get in touch with you?
Oh, well, we're Paxauris. That's Paxauris, and you can go to our website. We have a newsletter which you could subscribe to find out what we're doing. Our company is making a new type of earplug for hearing protection, and actually for anyone who wants quiet. Our motto is a better way to quiet, and Paxauris itself is Latin for peaceful ear. And our earplugs are super cool. We've been funded by the Army and the Navy to develop them. It's a fluid inflatable earplug, so you stick it in your ear and you push a bulb, it inflates there with a nice, soft, secure acoustic seal. And we think it's going to revolutionize the way people enjoy their lives in quiet.
That just makes so much sense to me.
Doesn't
an inflatable earplug, right? It just naturally conforms to the contour of your ear and organically creates a seal that makes so much sense.
You stick it in, push the bulb, and it inflates.
Oh, brilliant.
I'm just showing Aaron here, but you can't see this, the folks on the podcast.
They'll have to go to your website, Paxauris, and check that out for themselves.
Right.
Now, are you selling this to, is this just like a commercial product? You mentioned the Army, or can, anyone go out and buy one of these?
We're taking pre-orders now. Actually, when the new website goes live next week, we'll be taking pre-orders. But right now we're in kind of the pilot study phase. So we're testing them with the Navy and with some industrial early adopters, and pretty soon with the Phoenix Police Force. And just to get customer feedback before we scale, and that's the next part is right now we're at that low volume where we can't bring the price down yet, but in the next 6 months we'll be scaling, or even 3 months we'll be scaling up our manufacturing so that we'll be able to sell them in volume to consumers.
Super exciting. Now, this is passive noise cancellation, not active. Is that accurate?
Yeah, we have the earplugs passive. We also have a hearable, which is an electronic device. It also relies on passive hearing protection, but it actually measures the amount of noise inside your ear canal, so your actual noise dose. And it has the transparent hear-through, so you can still hear your environment for situational awareness and communications, but if there's a loud sound like a gunshot or explosion or a jet taking off, it'll reduce the hear-through to safe levels.
Okay. Just for a point of reference here, how does the Paxauris earplug compare against something like Apple AirPods Pro with active noise cancellation?
In terms of attenuation, they're similar. However, the AirPod Pro will give you the noise reduction works up to the sound hits a certain level where the AirPod Pro can't overdrive it anymore or can't cancel it, and beyond that, the sound could become damaging. Whereas the passive noise reduction is independent of the sound level. Mm. And our fit is much better. 50% of people, a few studies have shown, if you've got an ear that works for the AirPod Pro, that's great. If you don't, then the seal which you're getting may not be as good. Whereas fluid seal works for a broader range of people. Yeah,
that's a huge deal, that seal that just naturally form fits to your own anatomy.
Right. That's why you get the AirPod Pros, they'll come with 8 or 10 different tips to try to get one that fits. And some folks, I'm one of them. I just can't get it to fit.
So it sounds like the Paxauris earplugs, I'm sure they're useful for, any environment where you want to attenuate noise. It sounds like they might be especially useful for environments they're especially loud, because there's no real limit to, the max decibel level that it can reduce that noise, right?
Yeah, it'll always give you 30 decibels or 26 decibels, no matter what the level. But the real advantage is that it's consistent. So a foam tip, could give you anywhere from 10 to 30 decibels, depending on the fit, whereas our fit is more repeatable amongst different people because we get a consistent fit. And the other is just how easy it is to put it in and out. If you're finding you need to put earplugs in and out a lot during the day, then ours is a good solution.
Great. Wonderful. Well, Tony, thank you again so much for being on the podcast. What a delight getting to know you.
Yeah, thanks for doing this, Aaron. I think wonderful questions. You've also put a lot of thought into this, and I think it's a worthy goal to increase the speed of engineering safely and efficiently.
Thank you very much, Tony. I appreciate it. Very kind of you to say. I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.